Yes, how are you, dear student? As I promised you, I said that today I will be taking you through the linear programming, the remaining concept of our work. And actually, I know there is something I shared with you to go and read on your own. There is what we maybe are the definition of linear programming. Please go and read on definition of linear programming, what are the requirements of linear programming, and maybe the application, the assumptions of linear programming. Please go and read on them. I share the note with you through the online platform. You can also read on advantages of linear programming, disadvantages of linear programming. So today we shall be talking about formulation of linear programming. How do you formulate linear programming? Formulation of linear programming, and we shall be guided by a question from past paper, which will now be the December 2021. This is the question that will guide us. December 2021, question number 5. So what are the basic? This question, I know you have it, December 2021, question number 5, which I'll show you how to formulate linear programming, and then we are going to solve the linear programming using the different methods. There are two methods of solving linear programming. One is graphical method, and then we shall come to simplex approach. The question reads, Bantu Limited makes two types of pudding, vanilla and chocolate. Each serving of vanilla pudding requires 2 teaspoons of sugar and 25 ml of water. And each serving of chocolate pudding requires 3 teaspoons of sugar and 15 full measures of water. Bantu Limited has available each day that 600 teaspoons of sugar and 500 full of measures of water. Bantu Limited makes no more than 600 serving of vanilla pudding because that is all it can sell each day. Bantu Limited makes a profit of 10 shillings on each vanilla pudding and 7 shillings on each chocolate pudding. So, number 1, we formulate linear programming problem. So the first step is the key decision. What is the key decision here? The key decision is making vanilla and chocolate puddings. So we can come and say, let the number of vanilla be X and let the number of chocolate, or we can just use B and C, B, B, this one be C. Then the other thing is what we call, another key thing is the objective. According to the question, the major objective is to maximize profit. So we are going to say maximize profit, and each unit of vanilla is close to 10 shillings. It will be 10B plus, and each serving of chocolate is close, the profit is 7 shillings, 7C. Another thing we come up with is what we call the constraint. We need to come up with a constraint. Constraints are a limiting factor. And in this case, we are going to have what we call, I can see the keywords here, there. We are making vanilla, as you have seen, and chocolate. Vanilla and chocolate. So we can say, a teaspoon of sugar. We require, for vanilla, we require how many teaspoons of sugar? 2. And for chocolate, we require how many? For vanilla, we require, and then there is full of water. Full of water. So vanilla requires 2 teaspoons of sugar and 25 full of water. Then we are told for chocolate, we require 3 teaspoons of sugar, 3 teaspoons of sugar, and 15 full of water. 15 full of water. There is what is available for a given time. We are told that the available teaspoon of sugar is at 600 and full of water is 22,500. Then we are also told that you cannot make more than 6 servings of vanilla. So you cannot make more than 6. So if you have to come and formulate this, you come and say it will be the same as, if you can go to this side, higher 2V plus 3C. Then we are using this inequality. Why this? Because we are told the available. You cannot exceed that 600. That's the available. The other one will be fruit of water 25V plus 15C. The available is 22,500. You cannot exceed that. Then vanilla, we are told you cannot make more than 600. You cannot make more than 600 for vanillas. And then there is what we call a negativity. Now negativity tells us V and C cannot be negative. V and C cannot be negative. So if we are going to formulate the entire linear programming problem, formulating the linear programming problem will be to come and say, how we have there, we have seen that, we come and say we are maximizing profit. You can just call it Z. Z can stand for profit. And each, the profit for one serving of vanilla is 10V plus 7C. ST. What does ST stand for? Subject to which are these constraints. In as far as we want to make profit, we are limited by this constraint. And one of it is 2V, 3C, that is 600. This one is, we have seen, is teaspoon of sugar. Then we have 25V plus 15C. The available is 22,500 fruit of water. And then another constraint is V, 600. Why are we using less than or equals to? Because you cannot exceed the available, the given one. So in this case, it will be number of vanilla. Then you bring the issue of non-negativity, that is V and C. So this is complete linear programming, which now answers part number 1. Answers part number 1. So objective, S stands for subject to. We are limited by this constraint. Where can we use greater than? In case you are told, for example, it is at least or than 6 and above. So in that case, it is a case of more. But this one we are told that 600 to 2,500 tell us you cannot exceed that. After you complete linear programming model, there are 2 ways of solving. And the first one is the graphical method. I use the same case to solve using the graphical method. Let us use the graphical method. Graphical method means you draw the graph. Like now in this case, you have 2V plus 3C equals to 600. We can have V and C. Like now you can say, when V is 0, what is C? When V is 0, what is C? C is 1200. Then when C is 0, what is V? 1800. 1800. Then you can think, for example, like you can say, when C is 1, you just need 3 points. When C is 1,000, what is V? 3,000, it will be 300. So that is one. The other one is what we are saying, 25V plus 15C equals to 500. So then we say V again and C. When V is 0, what is C? When V is 0, what is T? That is 1500. When C is 0, C is 0, what is V? That one we can probably use the calculator to see. So you just need 3 points when you are counting this. So you just come and say, when C is 0, 22,500 divided by 25, you get 9,000 or mean 900. When C is, maybe you can say when C is 1,000, what is V? So it will be 22,500 minus 15,000 divided by 25. You get 300. Just leave what I now for the graph. Then you say, so the other part will be V equals to 600. V equals to 600. So that's what you now come to the other side, you draw the graph. So this one you just come up with the graph, show how you can solve it using linear programming. So that is one. We need x, this one will be this one we can call it y-axis. Let me try to draw a straight line. Y-axis. So this one will be y-axis, and this is x. So we can use a scale of the highest here is 1800. So a scale of 200, 400, 600, 800, 1000, 1200, 1400, 1600, and then maybe 1800. Once again here, 800, 1000, 1400, 1600, 800. So we are using a scale of 200, 200. So this one we can call it, we can use vanilla on this side, and we can use chocolate. This one can be chocolate on this side. So this one will be chocolate. So x-axis we will have vanilla pudding, chocolate pudding on y-axis. So we start with this now. When B is 0, C is 1200, 0, remember 0 is here, 1200, 1800, 0, you go about them, 300, 1000. 300 is between 200 and 400, so you have it here. Then you join them. Especially this one is advisable you do it in the graph. A graph will give you a straight line, not like this one we are doing here. Then you come and name them, which is 2b plus 3c equals to 600. Then you have the other one will be 1500. 1500 is here. 900, 0. 900 is between 800, 1000, 300, 1000. So then you join there. So this one will be 25b plus 15c is 2500. Then last time we have b is 600. Remember there was another one which is b is 600. And because this is vanilla, this one we just have a straight line. V equals to 600. Now the question is, which side are we going to shape? We always compare basing on the origin. Because remember here there is what we call wanted and unwanted side. Like in this case, let us take the coordinate which is, we assume it is 0, 0. 0, 0 you substitute here. Why are we taking, provided our line does not go from here, we use this as the basis of knowing which one we are going to shape and which one is we are not going to shape. So 0 plus 0 is like 6. We can say that the 600, 0 is less than 600. 0 is less than 600. So that means this one will be unwanted, but this is a wanted. Because it's one which agree with the fact that 0 is less than 600. So we shape this. The same case applies to the others. Even when you take 0 and 0, 0 is less than 22,500. So this one will be unwanted. And this will be unwanted. Then there is what we call a negativity. Answer cannot be negative. So this is what we call feasible solution. In other words, our answer lies there. Solution. Hope you can see this. Our answer lies there. But to determine which one is the optimal, we get what we call the corner solution. Get the corner here, A, E. But to know which is the optimal, we will come here at the same point, then coordinate, and then we shall have what we call, remember that it was maximum. We are maximizing the one which will give us the maximum profit. Say 10B plus 7C. And let us start with A, B, C, D, E. Point A, the coordinate is 0, 0, so that means the profit will be 0. When you substitute there, it will be 0. B, 0, 1200. So we can substitute 10 plus 7, 1200. This is 400. And see that. C, what is C? C is 300 and 1,000. At least you can see C lies between 300 and 1,000. 300 and 1,000. And 1,000. So this one will be 10, 300 plus 7, 1,000, which will be 10,000. E, D. The coordinate of D is 600 and 500. Yes, 600. At least if you are using the graph, it can be more accurate. 600. The coordinate of B, X, 500. 7,500. Higher than E. E is 600 and 0. So E, we say 10, 600 plus 7, 0. So this one is 6,000. This one is 6,000 plus E, 95. Now, which one has given us the highest? Which one has given us the highest? Remember the question was, we are maximizing profit. So which one has given us the maximum profit? In that case, it is point D. So it will now be this decision variable will be as follows. The point which has given us, so you make vanilla, which is now 600, the one which has given us is C, because C has given us 10,000. So in this case, vanilla you make 300, chocolate will be 1,000. Then your maximum profit will be 10,000. Why have we taken this? We were maximizing profit. We want with the point which will give us the maximum profit. The point which will give us, which is now this. So at least we can say at point C, that is where the profit is maximized. This is graphical. You just know anything you're talking about less than or equals to, and shaded will be the other side because we compare it against 0. Provided our right has to go to 0. So this is now the graphical. I have shared more questions on this. Please you can go and find the notes which I gave you. But I want now to go to the other stage, which now we work with simplex. Simplex method, that was graphical. We are going to use the same question to work with using now the simplex method. Remember, simplex method, it will follow the same procedure in terms of formulating. So we are formulating, the procedure will be there. But now this one is a bit complex. It's a bit complex, but we are going to work it. Simplex. So at this graphical as normally, you can follow the questions given on the graphical. But now when we come to using there are steps which are shared in your notes. There are some steps I gave on how to work this using the simplex method. And one of the steps is using now the simplex or algebraic method is set up the problem just like this. You set up the problem, or rather you formulate the model we have done, convert the inequality into equation by adding one slack variable. So now when we are working on this, we convert this into slack variables. How we do this? You come and say max z. You bring this to the other side, say minus 10b minus 7c equals to 0. Then ask one slack variable plus 3c plus s1. Why s1? Oh, this is constraint 1, that is 625b plus 15C, you add slack variable 2 because it's constraint number 2. Then V, you add slack 3 because it's constraint number 2. 3 I mean 600. So this is the initial step. You add the slack value. You add the slack value depending on how many constraints you have. If you have 4, you have 4 slack value. Then after that, maybe for space allow me to remove this because we need more space of this. We will come and now have what we call initial simplex table. And that will answer part number 2. Initial simplex table, which is now we always have what we call bases. Higher. Then we have how many variables we have? V, C, S1, S2, S3, and solution. Then basis we always start with the slack variables. S1, S2, S3, then the last column is maximize Z. So this is the first basis. How are we going to do this? Sorry, I'm writing down because this question we need more space. We need more space, that's what I'm trying to do. So according to this, 2, you have for slack equation number 1, we have 2, 3, 1, because it's slack 0, then the others will be 0. Solution is 3600. The other will be 25, 15, 0, 1, 0, 22, 500. Then lastly we have 1, 0, 0, 0, 1, 600. And then this one will have negative 10, negative 7, 0, 0, 0, 0. This is the initial simplex table. And according to the step which we say, we see the first step. Convert the inequality into equation by adding slack variable for each inequality. That's what we have done there. Construct initial simplex table like the objective at the bottom. That's what we have done. And remember these are negative. Number 4, the most negative entry in the bottom identify the pivot column. The most negative is minus 10. So this now become pivot column. Please note that. This now become pivot column because it has the most negative. Then we say the smallest, calculate the quotient. How we calculate this quotient? We come and say at the end, now that we have known this is the pivot, and remember, I will come and say divided by 2, 1800, divided by 25, and then pattern 900, but just you can always confirm. We have said 22, 500, divided by 25 is 900, 600 divided by 1, 600. Now, which is the smallest quotient between 1800, 900, and 600? The smallest quotient there is 1. So this is the smallest. So this will be the pivot element. And now what we do, once we get the pivot element, we will make this value become 1 or the others will be 0. Remember, this is the pivot element. This become 1 or the other become 0. So let me show we prepare another table. How are we going to know whether we are correct until all these values become positive? Once they become positive, we know that we have come to the order. Another thing we need to note is that if any of these values is negative or 0, we ignore it when we are getting the quotient. So if we are getting the quotient, if we realize a number is 0, that one you want to consider that. And the one which gives you the smallest quotient, which is 600, become the pivot element. So I will have another table which will be basis V, C, S1, S2, S3, solution. So then you have this one will come and replace S3. Remember when they intersect, it will come and so you have S1, S2, we are taking, V will now take the place of S3 because we have determined this is the pivot element, column and row. Why we say this is pivot element? Where the pivot, row, and the column intersect. And therefore this will come and take the place of that. Then maximize Z. So that is what we shall have as the first one. We now, this one we should be 1, all the other one should be 0. So this one will be 1, 0, 0, 1, 600. Now all the other value will be 0. Remember, like in this case, if one value is 1, all the others become 0. So how can we make all the other value become 0? Like if we want this number to become 0, this is how we do it. We are going to come and say, this is called neural field. This is the order of 1, order of 2, order of 3, order of 4. Or neural 1, neural 2, neural 3, neural 4. So we can just call this say, I want neural 1 using order of 1 and neural 3. Why neural 3? Because this is the first way to obtain the values, and we can see this value is 1. Higher. Order, we want this to become 0, but order 1 was 2. So it will be 2, and this is 1. The neural 3 is 1. How are we going to make this 1? It means neural 1 equals to order 1 minus neural 3. So, 2 or 3. So in other words, if you say 2 minus 2 in bracket 1, it will be 0. And this is what you do to all the other values. Ya pili itakuwa 3, and because this is 0, if all these are 0, this means it will not change. So this one will be 3, 1, 0, but this will change because now it will be, that is now the third one, 0 minus 2 in bracket 1, which is minus 2. Higher then, last we used that 600 in the old one, that 600 minus 2 in bracket 600. So we are saying, how do we get there? We are saying, so this one is saying that 600 minus 2 in bracket, which is that 600 minus 1200, you get 2400. So now to get the neural 2, because we also need neural 2, we use order 2 and neural 3. Neural 3 is 1, we want this to become 0. Na pale ilikuwa ni, pale ilikuwa 25. How do we make it become 0? So here it was 25. So it will be neural 2 equals order 2 minus 25, neural 3. 25, neural 3. So we say 25 minus 25 in bracket, this is 0. 15, so this, if this is 0, having a 0, that means 15, 0, 1 remain. 0 and 1 remain, but this one will change. 0 minus 25 in bracket 1 minus 25. 22, 500 minus 25. So 25 times 600, then minus 22, 500 minus 15,000. You will get 7500. You now come to the last one, which is neural 4. Remember, neural 1, neural 2, neural 3, neural 4. Use order 4 and neural 3. Remember, we are working with neural 3. We are now working with this. So order 4 equals minus 10. This is 1, and we want it to become 0. In other words, ikuje 0 hapa. So how do we do this? And then the other which we are adding, subtracting, this one you are going to add. So we say neural 4 equals to new order of 4 I mean, plus neural 3. So we add negative 10 plus 10 in bracket 1 is 0. So this one will be negative 7, 0. 0. Why are they remaining? Because these are 0. If they are given, they remain. 0 plus 10 in bracket 1 is 10. 0 plus 10 in bracket 600 is 6,000. The question is, have we come to the optimum or not? Have we reached the optimum? I would say no. Why say no? As long as you can see the negative value, we are yet to come to the optimum. But how do you know about which is the pivot column? Pivot column where we have the negative. This is the pivot column. So we are going to have a say divided by 3, 1200, divided by 50, 75, divided So you get 500. This one higher. We can also, this one we are going to ignore. We say if this is 0 or negative, we are going to ignore this. So we are going to compare the two. Which is the smallest quotient? It is 500. So the pivot element is where pivot column and pivot row meet. Because this is where we have the smallest quotient. So we come up with, we make this to be 1 and all the other one to be 0. In the same column, 1 or the other to be 0. So we prepare another table. They say this is now the learning table. B, C, X1, X2, X3, solution. So now SC will come and replace S2. So we are going to have S1, C now replace S2, C, B, and Z. Hope you are following. But of course there are more questions on this one. You divide, how do you make this one? Divide by 15. So 15 divided by 15 is 1. So this is 0, 1, 0, 1 over 15. Because you are divided by 15. This one negative 25 divided by 15 is negative 5 over 3. Divide is 500. Now you make all the other values in that column to be 0. Like this, how are we going to make this to become 0? Because once this is 1, all the other values must become 0. Let us say neuro 1. Remember, this is now neuro 1, neuro 2, neuro 3, and this is the first element to obtain. So this becomes our basis of getting all the other values. So neuro 1 uses all 1 and neuro 2. Why neuro 2? Because this is now the neuro to obtain first. This is the neuro to obtain first. So neuro 1 to 0, all 1 was in the same column. Remember, in the same column where we have the pivot element, what was the old value there? The old value was 3. So this is 3 and we want to become 1. So this one is minus neuro 1 cos old 1 minus neuro 3. So remember, this one remains 0, 1, this is 0. 3 minus 1 in bracket 3 is 0, at least we have managed. This delay, so this is 0. Then we have 0 minus 3 in bracket 1 over 15. 0 minus 3 in bracket 1 over 15, negative 1 over 5. Negative 2 minus 3 in bracket is. So we are saying negative 2. Remember negative 2 here. Negative 2 minus 3 in bracket 5 over 3, which is the same as negative 2. Minus 5. What do you get? Z3. So we just remember this and so negative 2. Then we have minus to become plus. So that will become 3. Allow 2400 minus 3 in bracket 500. 2400 minus 3 in bracket 500, which is 900. So now, luckily, already this is 0. In other words, it is already in the form that we need it to be. So that means this rule will remain. Why is it remaining? Because already this is 0. So we just come and say this will be, already this is 0. 1, 600. Then we get the last one. We want also this to become 0. How do we do it? Neuro 4 equals to all of 4. You see neuro 2. We are using neuro 2. We want this to become 0 and it is minus 7. The same, minus 7, and this one is 1. Remember, neuro 2 was the first one, so it will be neuro 4 equals to all of 4 plus 7 neuro 2. So, higher 0 plus 7 in bracket, this is already 0, so it will remain 0. Negative 7 plus 7 in bracket 1 is 0. Higher 0, this one will remain. 0 plus 7 in bracket is 7 or 15. 0 plus, 10 plus 7 in bracket is, so it is 10 plus 7 in bracket, negative 5 over 3. So this is 10 minus 35 over 3. 10 minus 35 over 3, which will be 35 divided by 3. So it will be negative 5 over 3. So that means it is negative 5 over 3. Then we have 6,000 plus 7 in bracket 500. 6,000 plus 7 in bracket, this which is 500. The question is, have we come to the optimum? Yes or no? As long as there is a negative in the bottom row, we still have a journey to go. So we still have a step because all these values must become negative. I hope you are following, dear listener, but we have more examples from what I shared which can guide you. So let us prepare another problem because we are yet to come to the optimal higher. But which is the pivot column? In this case, our pivot column is this because it's the one which has more negative. Although it is the only negative in actual fact, the more negative. So you take the one which is more negative, and we can see it is this. So divide by 300. Divide by 300. You cannot divide. We say if it is negative, that one will not affect. Please note that if it is negative or 0, we cannot. So this one we ignore, divide by 600, which is the smallest quotient between 600 and 300. This becomes our pivot element. So that means S3 will come and replace S1. So we prepare another table. So there are no steps involved. So basis. Now this one will come and take the place of S1, S3, C, and V. Then Z, then we shall have V, C, S1, S2, S3. So please put your columns down to the end of this. So once we do that, how we make this to be 0 and all other elements will become negative? Hope we are getting that. It's not easy. But of course, with more practice, this question mostly comes in 10 months or even 0. So we divide by 3 and we do the same throughout the column. So this is 0, 0, 1 over 3. Negative 1 over 5 divided by 3 is negative 1 over 15. This is 1, 300. So we make all the other elements become 0 in this column. So let us take a view. Remember, we are now focusing on that. New row 2 using old row 1 and new row, old row 2 and new row 1. So old row 2, we want this to become 0 and equally negative 5 over 3. And this is 1. So this one means new row 2 equals to old row 2 plus 5 over 3, new row 1. Hope you can see that. So we are saying this remain because that was, if it is already 0, you know that is 0, they are going to remain the remaining 1. But this one will change. It now says 0 minus, 0 plus, it will just be what is here, 0 plus 5 over 3, in bracket 1 over 3, you get 5 over 9. And the other one, 1 over 15, to have us as 1 over 15 plus 5 over 3 in bracket 1 over 15, which is the same as 1 over 15, minus 1 over 9, which is negative 5 3 minus 5, we get negative 2 over 5. So remember this one will be 0 because if we take negative 5 over 3 plus 5 over 8, 1 will be 0. Then 500, these are just working, 500 plus 5 over 3, 300 will be, that one will be 1,000. So allow me to delete this because they are just working. Row 3, higher. New row 3, you can even write it here. New row 3. Hold row 3 and new row 1. The one that we got first. We want this to become 0. This is 1 because of this. Old was 1. Actually, this one is minus. So new row 3, old row 3 minus new row 1. You just minus. So you say 1 minus 0 is 1. 0 minus this is 0. 0 minus 1 over this, 1 over 3. 7 over 15 minus 7 over 15. Minus 1 over 15, you get 8 over 15. Then this one will be 1. This one, for this one, let me correct. So we are saying 0 minus 0. So this one we have started with 1 minus 1 is 1. 0 minus 0 is 0. 0 minus 1 over this minus 1 over 3. 0 minus 0 minus 1 over 15 is 1 over 15. Then 1 minus 1 is 0. 600 minus 300 is 300. You can see this. Last time, how do we make this to be 0? You come and say new row 4 equals to old row 4 and new row 1. Remember, we are comparing against this, the one we obtained and the old one. So this one was minus 5 and 3, the old. We want this to become 0 and this is 1 because remember the pivot column was here. So we are basing it on here. So this one will be new row 4 equals to old row 4 plus 5 over 3 new row 1. So we now say 0 plus this one remain because they are 0. 0 plus 5 over 3 in bracket, this is 5 over 9. 7 over 15 plus 5 over 3, negative 1 over 15. That one is 7 over 15 minus 1 over 9. 7 over 15 minus 1 over 9. So this one we can say 45 square root 321 minus 5, you get 17. Because 3 times 7 is 21 minus 5, 17 over 45. Last time, this one will be 0. Then 9500 plus 5 over 3 in bracket. This was 300. Remember, this is solution. You get 10,000. Have we reached the optimum? Yes or no? I will say yes, because all the value in the bottom row qualify to be positive. So this is the farthest we can go. And how we make the decision, allow me to create this. These are just to guide us get this in the format. And also we have more questions from the notes I shared. So our last time, we will come and now say, once we come to the optimum, how do we know we have come to the optimum? When the bottom values are negative. If all of them are negative, we say we are optimum. There is now the decision variable which agree with what we saw. We can say C is equals to, that was chocolate 1000. You can confirm whether that is what we got. 300, and then maximum profit or maximum Z is 10,000. That is the same thing we got. Then there are things we call slack variable. Please pay attention to this. I will be explaining what they are. Slack value S1 is S1 in the basis, yes or no? If it is not in the basis, S1 is 0, S2 is 0, they are not in the basis, but S3 is now 300. This means these are scarce. The two resources, resource 1 and resource 2 from our original equation, they are scarce. In other words, they are limited in supply. Resource 1 and resource 2 are scarce, but resource 3 is in abundance. So this one we can say it is abundant. In other words, it is in excess of what is needed by 300. There is what we call shallow price. We are writing constraint 2 and constraint 3. We are saying they are under slack value. Remember these are the slack values. If therefore constraint 1 is 5.9, constraint 2 is 17.5, and the constraint 3 is 0. Why is it 0? Because already this was in excess. If it was in excess, the shadow price would be 0. But for scarce one, the shadow price would be 0. How do we interpret this? Like for the constraint 1, we are saying, if you increase resource 1 by 1 unit, the profit will increase by 5/9. If you increase resource 2 by 1 unit, say it was food of water. If you increase food of water, which was constraint number 2, by 1 liter, the profit will go up by 17.45 shillings. But for the constraint number 3, even if you increase, it will not affect because it is already in excess. Please mark this decision variable. Maximum slack value, we get them from here, like S1, S2, they are not there, so they are 0. And then the sharp price we obtain them, where we have the slack value below, so like this now become the slack value. Then how do we know it is optimal? When all these values are non-negative. Thank you for listening to me. That is what I promised to cover, and we have done it now. There are more questions I shared with you. Please go and follow them, and you are going to understand the concept in a clear and better way. Otherwise, I wish you the best in your coming exam, which are starting on Monday. Please revise. If you have any issue, get back to me in our system. Thank you. Success in the exam.